Hello everyone, and welcome back to another cartography lecture video. In this lecture video, I want to finalize our discussion on types of data by talking about the other two levels. So in the previous video, we discussed the first two levels, which were nominal and ordinal. And we said that nominal was the idea that you have no numeric meaning and no order. And this would be things like labels or descriptive terms. So things like names, color, and then IDs. And ordinal had no numeric meaning, but the values had an implied ranking to them. So this would have been something like places at the end of a race or quality statements, where you could say that great was better than good, was better than okay, was better than poor. And what defined both of these levels was that you could not do math on them, right? Even if you represented these by numbers, it didn't make sense to do any sort of multiplication, addition, or subtraction. So what I want to do in this video is I want to continue our discussion by talking about the other two levels. And I want to present them at the same time because they're very similar, and their distinguishing characteristic is best described when we can compare them simultaneously. And so the last two levels are going to be interval and ratio. And so interval and ratio are both numeric values. So these are going to be the things that you probably typically think of when you think of data. So they both are numeric values, or put another way, the numbers have numeric meaning. Okay, so they're both numeric values. So this would be something like, for example, 1, 2, 3, 4, decimal points, fractions, pi, right? These are all numeric values. But what separates the two is this idea of an arbitrary zero. So an interval data has an arbitrary zero, and ratio data has what's called an absolute zero. Right, so the difference between the two is that interval data has this arbitrary zero, and ratio data has this absolute zero. And this is the key distinguishing feature between them, and that's why I wanted to present them simultaneously so that we can talk about this idea of arbitrary versus absolute. So the way that I think of arbitrary and absolute zeros is from the perspective of negative number, of what does zero mean and negative numbers. So the way to tell if you have an arbitrary or an absolute zero is going to be whether or not negative numbers make sense right? Do negative numbers make sense? And does zero mean zero? Right? Think of these two questions, and the answers will tell you whether or not you have an arbitrary zero, which means interval, or whether you have an absolute zero, which means ratio. And so, do negative numbers make sense? I think the best way to sort of tackle this is going to be through examples. So what I want to do is I want to go through 4 examples, and I want to think through what these questions mean and try to separate them out as examples of interval or as examples of ratio. So let's start off with temperature, specifically temperature measured in degrees Fahrenheit and degrees Celsius. So let's tackle this first question. Do negative numbers make sense? Well, hopefully you come back with the answer of course negative numbers make sense, right? In the winter, at least in the northern hemisphere in New York, right, we reach temperatures that are below zero, which would be a negative number, and that's not uncommon, right? It makes sense to have a negative number. And then does 0 mean 0? So what does it mean to have a value of 0 degrees for Fahrenheit or Celsius? I can tell you what it does not mean, right? It does not mean that there is 0 heat, right? So in this case, for temperature, right, a value of 0 doesn't mean 0, right? It doesn't mean that there is nothing of that quantity. And because of that, right, negative numbers make sense, right? You can go below 0. So that means that we have an arbitrary 0, which means we have an interval data set. So temperature right, at least as measured in degrees Fahrenheit and degrees Celsius, right, would be an example of interval data. So let's go ahead and talk about the idea of money, right? We can keep it simple and we'll say money in your bank account. So let's go ahead and look at both of these questions, negative numbers and does 0 mean 0? So let's talk about does 0 mean 0? What would it mean if you had no money, right, $0 in your bank account? Well, that would mean, so what does it mean to have $0 in your bank account? Well, unlike with temperature, where 0 didn't mean 0 heat, $0 means you have no money. So in that case, 0 actually means 0. And let's talk about negative numbers for a second. What does negative numbers mean in the context of your bank account? Well, that would mean that you actually owe someone money. And although this technically kind of makes sense, it doesn't make sense in the real construct, right? Because negative money is sort of an artificial construct. So negative numbers actually don't make sense, not really. And so in this case, right, the amount of money you have in your bank account would be a ratio. Right, so dollars in the bank. Right, that's an example of ratio because 0 means 0 and negative numbers don't make sense. So now what I want to do is I want to talk about temperature again, but in this case I want to convert from talking about temperature in Fahrenheit to talking about temperature in Kelvin. So for those of you that aren't familiar, Kelvin is an alternative way of measuring temperature that is based on the idea of measuring how much heat an object has in it. Okay? So what would it mean for temperature measured in Kelvin to have a value of 0? Well, because Kelvin is a measure of the amount of heat that an object has, a value of 0 would mean that the object has no heat. Right? So in that case, right, does 0 mean 0? In this case, yes, it does, right? Because 0 means 0 heat. It has 0 energy left to produce heat. And so in this case, 0 means 0. Does a negative number make sense? Well, because we've defined Kelvin to mean 0 means 0 energy, you can't have negative energy, so negative numbers don't make sense. So in this case, right, temperature as measured in Kelvin is actually a ratio. Right, temperature measured in degrees Kelvin is a ratio because 0 means 0 and negative numbers don't make sense. And if you're familiar with Kelvin, you might be familiar with the term absolute 0, right? Absolute 0, right? So in this case, the name absolute 0 associated with Kelvin implies by default that it has an absolute 0 and that it's ratio. Okay, so hopefully this differentiation between arbitrary and absolute 0 makes sense. What I want to do is I want to highlight the differences between interval and ratio. And the key difference is whether or not you can infer this idea of multiples. So, for example, if I were to say that some number is twice as big as another, right, that's a multiple. So I could say, for example, if I had $1,000 in the bank and you had $500 in the bank, right, I could say that I have twice as much money as you do. And that's because 0 is absolute, right? We have a fixed reference point that means 0. If we were to talk about temperature as measured in Fahrenheit or Fahrenheit or Celsius, right? If it was 50 degrees in New York, but 100 degrees in Arizona, right? From the perspective of this arbitrary 0, right, it wouldn't make mathematical sense to be able to say something like it's twice as hot. Because the 0, right, this reference point that we have is arbitrary. So basically, interval data, you can add and subtract. Ratio data, you can do things like multiplication. So hopefully this makes sense. And as always, if you have any questions, please reach out. Thank you.